turbo engine running.
Absolute genius.
Get this.
Welcome.
This is the show where we bring you
Science.
What that essentially means is
discoveries,
Advances.
Questions. Research.
technology.
Unbelievable.
Without further ado,
This is The Naked Scientists. Hello, welcome to The Naked Scientists, the programme where we bring you the latest breakthroughs in science, technology and medicine. With me, Chris Smith. Coming up, scientists successfully test a promising vaccine for pancreatic cancer, why Japan is finally casting off its remaining COVID-19 restrictions, and we'll explore how a scientist is turning Yellowstone's geology into stunning pieces of music. First up this week, we're all aware of messenger RNA vaccines, thanks largely to the role they helped to play in turning the tide against COVID-19. But before the pandemic had even begun, researchers in New York had been testing the same mRNA vaccine technology, but as a treatment for cancer. I've been speaking to Vinod Balachandran, who's a surgical oncologist at the Memorial Sloan Kettering Cancer Centre. This week, they announced that they've successfully tested a personalised mRNA vaccine for pancreatic cancer. This was administered after the patients had undergone surgery to remove their tumours. And so far, half of the trial participants have not seen their tumours return, suggesting the team are onto something that could be very big indeed.
For pancreatic cancer, which is soon to become the second deadliest cause of cancer deaths in the United States by 2025, there are really no effective treatments. About 88% die with our best current treatments. A rare 12% survive long-term. The reasons why they were able to do this were really unknown.
It's not just that those 12% present much earlier.
That's a good question. And certainly if you have treatment sooner, in general, outcomes are better. But this did not completely account for their exceptional long-term outcome, as we had compared them to patients who had presented with similar stage and received similar treatments. So our hypothesis was that perhaps there might be some immune activity contributing to their exceptional outcomes.
If this is an immune effect, what do you suspect then that the immune system would be going after?
The immune system, we now know, recognizes cancers. They accumulate genetic errors called mutations. These generate new proteins in these cancers that the human body has never seen before. And this allows the immune system to now recognize these growing cancers as foreign and potentially kill them. So this was an inspiration for our vaccine idea for a clinical trial.
The idea being that given that you know that in some, albeit rare groups of patients, if you make the right immune response, you seem to be able to cure yourself. Can we get the other 88% and persuade their immune system to cure them too with the help of a vaccine?
Exactly. So perhaps what is happening in the long-term survivors is the best case scenario, if you will. And can we now try to induce this best case scenario when it does not happen spontaneously by delivering the mutated proteins as vaccines to patients?
Presumably you therefore had to hunt around and find out in each patient what the constellation of mutated, altered proteins that their cancer was making were, so that you could then harness those as a personalised vaccine for that person's disease.
The strongest immune response found in these long-term survivors was specific or targeted towards mutations individual to every single patient's tumor. So to make a vaccine, this indicated that we would need to analyze the genetics of every single patient's tumor, identify the appropriate targets, and make a vaccine. So it would be a custom vaccine for every single patient, which of course has its own logistical challenges.
How did you make the vaccines?
We were immediately struck by the unique challenges that we would need to overcome for such a personalized vaccine approach, which would be, number one, you needed a vaccine delivery platform that would be fast, because cancer patients require fast treatment, and also a vaccine delivery platform where you could incorporate several targets. And we thought at the time the optimal technology to do this was to use mRNA.
So presumably what you did was to take the genetic signatures of the tumours from your patients, where you could see that there were specific changes in the proteins, and take the bits of genetic material as mRNA that corresponds to those and turn that into the vaccine.
Right. We started our clinical trial in December of 2019. So this was right before the pandemic. We did surgeries here in New York. And within 72 hours, we shipped the tumors to colleagues in Germany. We then analyzed the genetic composition of these tumors and then custom make a vaccine for every single patient and then deliver it back to us here in New York, where we give it to patients. And overall, we ended up treating 16 patients with our immune therapies, which included individualized mRNA vaccines.
And what was the outcome?
50% of the patients who received the vaccines responded. So half.
How long a follow-up do you now have on those responders? And are they all still doing well?
Right. So the follow-up we have on these patients is 18 months median follow-up. And at this time, we find that the responders have not seen their pancreatic cancers come back, in contrast to patients who did not generate an immune response to the vaccine, in whom the cancers came back on average about 13 months after surgery. Now, this is still a small phase 1 clinical trial, but we think the results are encouraging and now warrants broader testing in more pancreatic cancer patients going forward.
Vinod Balachandran, and he's just published those findings in the journal Nature. The aerospace startup Vast and Elon Musk's SpaceX have announced that they're going to team up and launch the first commercial space station in as soon as 2025. Nobody could dispute Vast's confidence in the project, with the company reportedly selling tickets for its first crewed mission already. So what should we make of the bold proposal? Well, David Whitehouse is a space scientist and he's author of Space 2069, The Future of Spaceflight. What can you tell us about this announcement, David?
It's a very interesting project, and it will probably go very far because Vast Space are integrated with SpaceX, Elon Musk's outfit. Now, lots of American companies and startups have interests in building small space stations, and most of them are touting for investment and for business. But Vast Space have got Elon Musk on side, so they have a small space station which is going to be launched by a Falcon 9 rocket, initially uncrewed. It's going to be tested in space. And this is not a very big satellite space station. It's the size of a moderately sized satellite, a communication satellite, for instance. So it's copable with for a small company. And then eventually, I suppose, the year or so later, when it's tested out, they will use a Dragon capsule that's already taken astronauts into orbit as a sort of mini space station and to and from the space station to go up and visit it.
Does this seem realistic? 2 years away seems an incredibly optimistic timescale. Or have they been doing so much work in the background that they are pretty confident they're going to deliver?
Well, this does seem to be credible, although you're quite right. Who knows how long it will take, because there could be some showstoppers along the way. And until it's actually ready to fly, you're never really quite sure. But they have got a working relationship with SpaceX. Now, they've built their Dragon capsule, as I said, which can fly independently in space for several days, and a crew of 4 went up in the last year or so and just orbited the Earth without docking with anybody and had a great mission. So they have, if you like, the backup of SpaceX. They don't have to reinvent the wheel. They don't have to redesign life support systems and heating systems, because presumably what will happen is when a crew visit Haven 1, Vast Space's first space station, they will live in the Dragon capsule and only go through the airlock to Haven 1 to carry out experiments. So they're using a lot of what SpaceX has already developed.
What sort of experience are they offering? Because when you say this is satellite-sized, it sounds pretty cramped.
Oh, yes, it will be nothing like the space station, the International Space Station. This will be a very small module, much smaller than the modules in which the astronauts live on the ISS, on the ISS. So it will be limited to simple experiments. But what they're hoping is, if it's a success, they can start building it up module by module and expanding it in the same way that the International Space Station did. But clearly, it's going to be very much more limited in terms of who can go there, how much equipment you can take up there, what you could bring back, compared to the ISS, which is a tremendous facility. But of course, the ISS is in its final years. It's going to be closed by 2030 at the latest, and Russia may pull out years before that. We don't know.
Do they see a gap in the market then? Is that the motivation for doing this? They see a space, if you will, opening up, and the decline of the ISS, the decline of international relations with previous collaborators like Russia, meaning that there is this opportunity which this collaboration is seeking to plug into?
You're quite right. There is an opportunity here because the ISS is in its declining years, because we can see an end to it, because the Russian component, although Russian collaboration on the ISS has been going on almost independently of the international situation, the Russian components are beyond their useful lifetime in many respects, and they're starting to break down more. They're starting to show their age. So the space station is going to wind down in a few years' time and become increasingly difficult to maintain. And NASA has said that it wants to see, and it will help fund, and it's already given money to 3 big aerospace corporations to develop smaller, specialized space stations to do research into materials, into biology, into technology development, and even small hotels. So Vast Space's Haven 1 fits into, if you like, what could be a fleet of smaller space stations specializing in a way that the ISS was a mega space station which did almost everything.
So it does have both a sort of commercial / research aspect and a recreational aspect. They're eager to plug into both.
They are indeed, because people will pay. There are, as we've seen with SpaceX, with other companies, there are people with a great deal of money who are willing to pay to go into space. SpaceX has already had several missions with its Dragon capsule to the space station or as an independent free-flying capsule, with people who are eminently qualified to carry out research, to fly and command the capsule, who are willing to pay a great deal of money for the mission. So as well as the founder of Vast Space, who I gather is a cryptocurrency billionaire, putting in $300 million of his own money, he could get probably more than that from a crew of 4 or one or several crewed missions with people paying to go buying a seat.
So watch this space. David Whitehouse, thank you very much indeed.
The Naked Scientists podcast is produced in association with Spitfire, cost-effective voice, internet and IP engineering services for UK businesses. Find out how Spitfire can empower your company at spitfire.co.uk.
Music in the programme is sponsored by Epidemic Sound. Perfect music for audio and video productions.
You're listening to The Naked Scientists with me, Chris Smith, and a Cambridge scientist has been attempting to turn seismic activity recorded in real time at Yellowstone National Park into music. Domenico Vicinanza is a senior lecturer at Anglia Ruskin University, and he's been telling me about his fascinating project.
The Origin is one of the seismometer that is a scientific device that is picking up Earth oscillation that is physically installed in the Yellowstone National Park in the US. Normally we're used to see seismographs as a squiggly lines drawn by by a needle on a piece of paper. So what I've done is writing a piece of code that was translating the oscillation of the needle into music oscillation. Imagine a melody that is going up and down exactly as the waveforms, as the needle is going up and down. So if the needle is drawing, for example, a upward movement followed by a downward movement, the melody will do exactly the same. It's going up and then it will be going down. The melody is tracing the same and it's reproducing the same kind of behavior the needle is speaking in Yellowstone. If the Earth is oscillating very dramatically, a lot of seismic activity, big spikes, the melody will have the same dramatic behavior. Big intervals, high notes, low notes, giving a faithful representation of what's happening in Yellowstone.
And to be clear, these are not earthquakes going on. These are small tremors that are just the way the planet works.
Yellowstone is one of the most seismically active areas of the United States, and it experiences an average of around 1,500 to 2,500 little earthquakes. The majority of them are too small to be felt by humans. The very fascinating things about Yellowstone's earthquakes or tremors is the fact half of them occur in swarms. They're actually clustered together. You can have mini earthquakes that can last for 1-2 days, to some of them they can last for months.
So what gave you the idea to turn them into music, and why?
I think there were mainly two things. The first one, we wanted to give a different perspective. We can actually listen to that. It actually has a really nice, interesting structure and offer a different way of perceiving and understanding science. Also, science can provide a different way to create music and create art.
It sort of adds an extra dimension to our ability to experience the data, doesn't it? So rather than just looking at a squiggly line or looking at a table full of numbers, you get to experience it viscerally through the musical representation.
That's very true. We believe that music and sound in general can be a very, very useful and special way of experiencing science. Our ears are much more sensitive to patterns and changes than our eyes. I think music offers a absolutely unbelievably unique window into science in a way that is directly talking to us. You can immediately understand the flavor of what's happening there. If it is calm, agitated, dramatic, jittery, we can get that just by listening to it. There is a special beauty in that.
Previously, you've done the Large Hadron Collider. You set the energy levels of the collisions there to music. So you've done hadrons, you've done earthquakes. What are you going to do next?
We are thinking about whales at the moment, using hydrophones, turning the sound of water vibrations and water creatures into melodies, offer a different perspective into marine biology, hopefully.
Music from an earthquake. I suppose you could say you can't fault it. Other possible interpretations? Rachmaninoff, perhaps? Data sonification scientist Domenico Vicinanza there, and playing us out to the beat of the Yellowstone National Park, flautist Alyssa Schwartz. Now, from rocks that can make beautiful music to fish that can sing in a bid to communicate with one another, our own Will Tingle has the story.
What you're hearing right now are fish. Singing fish. Okay, perhaps singing is somewhat inaccurate, but you can't deny there's something remarkable about the sound being made. These noises in question were recorded as part of a series of papers released by the International Quiet Ocean Experiment, a group of scientists hoping to survey and ID fish based on their acoustics all over the ocean. The IQOE has an offshoot organisation called the Global Library of Underwater Biological Sounds, or GLUBS, yes. And member Miles Parsons took me through how fish make these sounds and what they tell us about the fish in question.
These sounds are produced for many species by particular muscles that are used to contract around a swim bladder. A swim bladder is a little gaseous body that they normally use for buoyancy, but several species of fish have developed the ability to use that swim bladder to produce sound. So these muscles contract around it, they change the shape of the swim bladder, and as that's pulsating, it creates noise. So if you can imagine that you have a healthier fish, a bigger fish, they have longer, stronger muscles that can contract around that swim bladder, and that takes ever so slightly longer to do it. So they actually create a deeper sound because of that. And you'll actually find that in some species, the females that might be trying to meet a mate are attracted to the deepest sounding voice. So the size of the fish and the sounds it produces essentially are related, and the sound gives information about the fish producing the sound.
So these noises can create a handy sound profile when trying to ID fish in murky or dark water, much easier than having a look. But the fish aren't making the noises for us, so what are they trying to say?
There's quite a few reasons why fishes produce sound. The main one is realistically spawning, reproduction. They also make sounds in terms of territorial defense. There's also distress or alarm signals that they give off, and some species, we think, actually communicate to each other to talk about feeding. So you get what you have called an evening chorus, which is a lot of fish coming together. Now, whether or not the sound they produce is a byproduct of feeding, or it's actually fish calling en masse to tell others where the food is at, we're not quite sure. But there's a number of different reasons for why they produce sound.
So now we know how they do it and what they're trying to communicate. Do these noises change as the environment does? What causes a fish to change its tune?
It's all really related to the behavior that's associated with the sound. So if we use spawning as an example, in Australia we have in the Swan River, we've got a big fish called the mulloway, and this makes a loud croaking sound. If you listen through the hull of a boat, it sounds like someone farting. Now, that sound is produced with spawning, and they are trying to time their spawning for the maximum chances of success for their eggs. So it happens mostly after sunset. It happens when temperatures are high enough in the water for the fish to be able to spawn successfully. And it happens after high tide, when the tide will be taking the eggs out from the river out to sea. So realistically, lots of these spawning or whatever communication purposes they're using for sound can be related to long-term environmental effects. So you'll get daily patterns, you'll get tidal patterns, you can get lunar patterns, and you'll get seasonal patterns.
But the factors behind changing a fish's noise are not limited to naturally occurring events. Humans are never far from the subject of altering a natural habitat.
Yes, so the most typical one there is vessel noise. And you'll have some species of fish have been shown to stop calling when there's a vessel nearby. But one of the main problems really would be the communication space that they have if they're being exposed to noise. So if you think about it from the fish's point of view, you have a male trying to attract a female. The female can hear it a long distance away if it's nice and quiet, so you've got a good chance of them meeting up and having a successful mate. But if there's boats around, then those chances are much lower, mainly because they're using sound as their main method of meeting.
But sound and the marine environment isn't a complete match made in hell. There are still many good things that we can use marine acoustics for when it comes to protecting fish as well.
One of the uses that you've got is fisheries management. You can actually locate these fish by the timing of their calling and the sounds that they're making. So that means that you can work out when and where their best chances of spawning are. And you can use that to identify what we call essential fish habitat. And in some cases, you could have a space and timing-based closure of a fishery. So you can identify the periods where you don't want to have someone targeting them, and you can use that to help manage the fishery.
Will Tingle in conversation with marine biologist Miles Parsons. Now, perhaps in the wake of the World Health Organization announcing last week that COVID is no longer a crisis, but they say it does remain a threat, Japan's government has finally downgraded their legal status of the virus in the country. It essentially means that COVID's no longer in a special category, but will instead be treated among diseases like seasonal flu. This means that if there is a spike in the COVID rate, a state of emergency will now not be declared and people will be allowed to make their own decisions about how they conduct themselves. Japanese health officials, however, are still urging caution, and they've said they will now begin preparing for the next major public health crisis. So what should we make of it? Well, my colleague Rhys James has been speaking to Sir David Warren, who served as the UK's ambassador to Japan between 2008 and 2012. Sir David began by explaining why Tokyo has been so slow to cast off its COVID restrictions.
Japan has been wary about fully unlocking. That's certainly true. I think that when we look at Japan's reaction to the COVID pandemic worldwide, we are seeing a highly developed country with extremely good health systems and world-class science research, nevertheless extremely cautious about the risks of a pandemic hitherto not experienced by any nation. And Japan has, I think it is fair to say, probably erred on the side of minimizing risks as far as possible in dealing with the issue of COVID. Although one never wants to make too many generalizations of a cultural kind, there is a certain cultural issue there in terms of Japan's risk aversion, particularly when facing an unknown problem.
And the country's health chiefs are still urging caution to some extent. Why do you think that is, David?
I think they will be influenced in part by geopolitical concerns. Japan began to open up after a long period of restrictions late last year when it liberalized inward travel for foreign travelers as well as for foreigners who were not resident in Japan. But with the upsurge of cases in China, which followed Xi Jinping's sudden volte-face of anti-COVID policy measures in late 2022, I think the Japanese were hesitant about potential implications of a sudden upsurge of cases in China crossing over into Japan and what that would mean in terms of the Japanese health precautions. That wave has come and to a degree gone. And now I think the Japanese feel a little more confident in liberalizing the measures that they have put in place, both for foreign travelers generally and for Chinese travelers specifically.
And do you think that the approach to COVID relates very much to the country's experience of SARS in the early 2000s? I mean, the Health Ministry has said that it's preparing for the next public health crisis and even the next pandemic.
I think it does. The SARS experience is very specific. I've lived in Japan on and off over many years since the 1970s, and I know that Japan is a society which takes health extremely carefully, where mask wearing, if you fear that you have or might get an infection, is very common, where hygiene is extremely important. Those risk-averse behaviors definitely influence the development of Japanese policy. When I was in Japan in late 2022, not long after it had opened up, and I was there on my first trip back for over 3 years, I was struck that mask wearing, which I'd expected to be pretty widespread, was almost universal, including in the streets as well as in crowded trains and tubes. That requirements to have one's temperature taken when one went into almost any public or private building were very widespread. And you could see how assiduous the Japanese are in sticking to the letter as well as the spirit of anti-COVID precautions and checking that there's no danger of passing infections. So I think that we're seeing a final decision to liberalize, which reflects the WHO's announcement that the emergency has ended. But it's come after a period of extremely careful reflection, analysis, and great care in developing public policy.
And Japan's approach, of course, has had a huge impact on tourism, not least the Tokyo Games, which were postponed and then held under very strict circumstances. How much do you think the decision to kind of reopen and encourage tourists back to Japan has played in this decision, David?
I think it's represented an enormous element of the overall policy consideration. The number of foreign visitors plunged in Japan over the period of 2020-2021. Obviously, the money that they spend was a tiny fraction of what they were spending before the pandemic broke over us at the end of 2019. So I think there is a very strong economic case for liberalizing these restrictions as soon as they felt they reasonably could. And we've seen, maybe in common with a lot of other countries, the way in which the Japanese government have sought to keep these two elements in balance. opening up the country so that the country can begin to earn money, not just from tourists, but from business interaction, doing so carefully and cautiously so that they cannot be accused of putting the public's health at risk. But you're right, it's a very, very important element of this.
Former UK Ambassador to Japan, David Warren there, in conversation with Rhys James. And that's where we have to leave it this week, but do join us on Tuesday when we're delving into the subject of memory. We're going to take a closer look at how our brains work and what we remember and sometimes forget. The Naked Scientist comes to you from the University of Cambridge's Institute of Continuing Education. It's supported by Rolls-Royce. I'm Chris Smith. Thanks for listening, and until next time, goodbye.